Well, welcome to Chemistry Lab. Today we're going to be doing the distillation part of the distillation and electrolysis lab. I'm just going to follow the procedure. However, today I don't have any cobalt chloride, so ask your teacher when you get to that step. Okay? So step one of our procedure says to measure out 50 milliliters of soda in a graduated cylinder, which I have done. It says to pour into a large beaker. So we're going to pour this into our very large beaker here. Then it says to measure the mass of an empty small beaker. So when we weigh this mass, I'm going to bring the computer close here. But the mass of that small beaker is 49.4 49.40 grams. So we're going to place this beaker on top of the soda, okay, on top of a rubber stopper. We're now going to build what's called a cold finger. But we're going to make it out of aluminum foil. So I've made my aluminum foil here. And I'm just going to place that on top. I'm going to fill that cone with some ice. Okay. And now I'm going to turn the heat on, the hot plate. So what's happening is I have our 50 milliliters of soda here. I stole some root beer from Mr. Crockett. I then have our rubber stopper holding a small beaker above the platform with our cold finger, our aluminum foil, and our ice sitting on the top. So now that I'm on step 6, as you're reading along in your procedure, I've placed the entire setup on the hot plate and allowing the soda to boil until the ice in the cold finger melts. It says do not add more ice, and then making some observations. Note any changes in color, volume, or phase that you observe. So at this point in this video, I would speed it up. All right, so now we've made it to the full boiling of our soda. You can see that there's definitely condensation on the inside as this is warming up and then immediately cooling off from the ice on the top. It's hard to see in that cone. Try to turn it a little bit. I can't let it escape, so it's really foggy in there. But I'm describing to you that at that cone there's large drops of a clear liquid dropping into the smaller beaker that's on the inside. Again, that's really hard to see, so I'm going to make that description for you as we continue with this distillation. As we read through the procedure, we're going to do 2 tests of this vapor that we're forming here. So as we're watching this occur, at step 7, we're going to wait for the ice to melt. And after we do that, we're going to test the vapor with some burning wooden splint by sliding a glowing splint under the aluminum foil, but not putting the splint in the liquid. The second test at step 9, says we're going to test the vapor from the boiling liquid with cobalt chloride paper. We actually don't have any cobalt chloride paper, so I am going to describe to you what would be happening when we get to that step. So if, as this is occurring, oh, it's starting to drip. That's fun. See if I can turn it to where you can maybe see some of those big drops drip from the cone of the aluminum foil into that smaller beaker on the inside. So cobalt chloride paper is a blue paper, so you don't see it because we don't have any of that here. However, it tests for the presence of water leaking through tiny cracks in pipes or in porcelain. So people have used this in the past. When water is present, the test paper goes from blue to pink. So this is a test we'll do with this distillation procedure as well as with the electrolysis procedure. And I still have quite a bit of ice up here at the top, so we still have a while to go on this video. So, yep, just keep fast forwarding.
The trouble was
All right, so now our ice has melted all in the top. So we're going to run 2 tests to test this gas that we have formed. The first test, to test the vapor with a burning wooden splint. So I'm going to just back up here just a little bit. I'm going to strike a match away from myself. I am then going to burn a wooden splint. The reason we burn a wooden splint is because it's longer, right? So I'm going to have it smoldering as I lift up and test. And immediately that smolder went away, okay? Again, our second test in step 9 is to test the vapor from the boiling liquid with cobalt chloride paper. Again, we don't have any cobalt chloride paper, so we're going to pretend that if I stuck cobalt chloride paper, again, in that vapor, it would immediately go from blue to pink, okay? Now we are going to turn off this heat. We're going to remove our cold finger aluminum foil, which has water, not ice. Then we're going to use tongs. Somehow. Double tongue this thing because it is rocking in here. Whee! Okay. So now we have our small beaker that is quite toasty. And I'm just going to set the rest of this boiling soda to the side for our purposes. While that is cooling off just slightly, we are going to measure the total mass of the small beaker and the liquid that collected in that beaker, and then we're going to measure the volume of that liquid that has now been there. Okay? So, and what's left over in the large beaker. So we're going to take our little beaker. We're now going to take our little beaker and weigh what is in here. Let's just start over. So 110. Oh, too far. Okay. So from our scale, which is really bright because the window is very sunny today, I'm going to hold that up there. I would say 111 point, let's go 85. 111.85 grams as the mass of the liquid that we collected in the small beaker. We're then going to measure the volume of that in a graduated cylinder. So here is my graduated cylinder. Move that to the side here. So I'm going to pour in this clear liquid that we collected. Okay. And so that volume is, again, right here. Let's see if I can turn it to where you can see the numbers. So we're at 63.2. Again, you have to have that estimated digit, so we'll say 63.2 milliliters as the volume of that clear liquid. Then we also are going to measure the volume of the soda. I'm going to take out that stopper And so in the large beaker, our volume, we started with 50 milliliters. Okay. And so now, of that root beer, we have, you can see the 20, the meniscus is below that 5 mark, so we would say 24.9 milliliters for the volume of that soda at the end. So making your observations and your data for the distillation of soda lab. Have a good day. There's the bell.